So we've been finding area under the curve, yes? And under doesn't totally mean under. It means from the curve to the x-axis. So if it's below, you're going up. If it's above, you're going down, right? We're going curve to the x-axis. So we've been making these Riemann sums, right? We had the rectangles, the midpoint rectangles, the trapezoid. A quick way to represent area under the curve, okay, is with this symbol. It looks like this. Everybody draw. It's like a little s. Okay. It stands for sum because you're taking those rectangles and adding them all up. Its name is an integral. Okay. The number on the bottom represents the lower bound. The number on the top would be the upper bound. Okay. And then you're putting in your width, your base, and your height. So my width would be the change in x, and my height would be the function itself. So I would have something like f of x dx. Okay, where f of x represents the height, the dx represents the width, or the base of your rectangle. So you have the base of your rectangle and the height. So it's just a quick way to say the area under the curve. Okay, so that's all that symbol's representing. So in this, let's do example 5. In this graph, it says write a definite integral to represent the shaded region. So I would say, here's my integral. I'm going to add up all the areas from who to who. -5 to 4. So my lower bound is -5, and I'm going to 4. I want the area under. The name of this function is f of x. So there's my height times the change in the width would be dx. Oh, yeah, sorry. Why is that all goofy? The change in x, like the base of your rectangle. Okay, so again, that's the height of my function. That's the width of the little rectangle I'm drawing in there, okay? And that's all it is. So an integral is saying add up all those areas from -5 to 4 of the function f of x with whatever shape it's saying. So go ahead and read example 6 here. So we have a large department store opens at 9 a.m. and closes at 9 p.m. The rate at which people enter the store in people per hour is modeled by the function p prime of t, where t is the number of hours since 9 a.m. The table contains values of p prime at selected values. Answer the following question. So here it is. Use a left Riemann sum. You are using a left. You are making 3 subintervals. And you are only going, though, from where to where? 0 to 5. So you're not using this section. So put your rectangles in there. You need to make 3 rectangles between 0 and 5. Who's the first one going from? 0 to 2, then 2 to 4, and 4 to 5. Go ahead and do a left-hand Riemann sum. Bless you. These should be about like 1 minute type questions to set up. What's the base of the first rectangle? This is an approximation. What's our first base? This is all we did yesterday, guys. What's the first base? 2. What is the height on the left? 11. Plus, what's the next base? 2. What's the height on the left? 30. What's the next base? 1. And what's the height on the left? 54. Okay, and then again, you just approximate. You can throw that in your calculator. I'm not worried about that at the moment. Okay, now it does say indicate units of measure. So again, just to be clear, we are doing a rectangle. So we're doing base times height. P prime of t is measured in people per hour. Bless you. And we're multiplying by the change in the t, and t is measured in hours. So we are doing people per hour times the hour. So we are getting the change in people. So whatever number we get, that represents the amount of people. All right. Again, I really don't care about the number. I know we can multiply. Number 7, use a right Riemann sum. So set up your right Riemann sum. They're telling you the subintervals to use to approximate this value. Let's just worry about the setup. Use a right Riemann sum. And get the setup. You don't need to do this b minus a over n for this, so you have the table in front of you. So when you don't have it, you need that. Still talking about p prime. Okay, so from 4 to 5, what's our base? 1, and we want the height, we want a right Riemann sum. Who's our height on the right? 26, perfect. 5 to 6, what's our base? 1, height on the right? 21. 6 to 9, that base is 3, height on the right? 44. And then 9 to 12, the base is 3, height on the right? 0. Okay, again, I don't care about the number. You can all add in whatever on the calculator. Units are the most important thing. And again, you're just reading the table. P prime of t is people per hour times the change in the time, which is hours. So again, you're getting the number of people. All right, it's still talking about p prime, so yes, it's still the same table. This time you're going from 0 to 12, so now you're using the entire table, and you're doing a midpoint Riemann sum, and you're looking for 3 subintervals. So break it up into 3 subintervals from 0 to 12. Subintervals from 0 to 12, and midpoint, you're picking the height in the middle. Leo, you okay? Okay. All right. So it splits up nicely into groups of 3. 0 to 4, 4 to 6, 6 to 12. What's our first base? 4, and the height in the middle is 30. What's the next base? 2, height in the middle? 26, perfect. Last base? 6, height in the middle? 44. Okay, so again, base, height. I'm still doing p prime of t, which is people per hour, times the t's, which is hours. So I'm still getting the approximate amount of people. All right, I think we didn't use that as a quiz. Flip the page. Let's see, I got a lot to do today. Let's see, is there a trapezoid review one? All right, go ahead. Get 1, 2, 3 again. 1, 2, 3. Try to go 5 minutes max here. integral goes from one time to another, so that total amount. Again, the sum. These two say F, so they're corresponding to table F. This says G prime, corresponds to G prime. What's that? Eventually. That's not the crazy part. All right, I need 3 subintervals. Stop right now. All right, looking at the first one, I want to write Riemann sum with 3 subintervals. So broke it up 1, 2, 3. What should the first base be? 2, height on the right, 2. Next base, 1, height on the right. Perfect. Next base, and height on the right. Beautiful. We getting the idea? Left Riemann sum, 3 subintervals. So same idea, 3 subintervals. We just now want the height on the left. So the bases are still all the same. Would you agree with that? The only thing that's changing is the heights now. Now I want the height on the left. So this base, or this height would be a 6, 2, and 5. Sound good? All right, midpoint Riemann sum with 3 subintervals from 0 to 12. So I'm using the whole table. I want 3 subintervals, so I think that breaks up into 3, 3, 3. Again, the bases may not be the same, and that's okay. The first base is a base of, does 2 sound right? Height is 4.7. We're good? Okay. Next base is a base of 6, height is 5.6. Next base looks like 4. Height is 4.3. Everyone feeling good? Okay. I'm just going to jump down to this one real quick. Number 5. The graph of G is shown. Write an integral that represents the shaded region. So again, integral means, it's an S for sum, add up all the areas from who to who? -4 to 3, and my function is named g of x. So again, that's the height. Now I need the width, so I put dx. So again, g of x represents the height. dx means like the change in x represents the width. So again, it's base times height, length times width, whatever you're thinking. Okay, now we're moving on to the crazy day. Typically I'd spend a full 2 days on this, but with everybody leaving, we gotta move here. All right, page 266. And you guys can do the other stuff tomorrow. We're going to go out of order. All right, this is a little crazy today, so I'm going to warn you. Let me just start with this. But we got to do it, and here we go. Okay, so let's say you take this function, and I put one rectangle in. All right, what type is it, a left or right? Left. I went up on the left till I hit the function. Left. All right. Is this an under or over approximation? Under. I have all this dead space, right? Now if I put in, let's go 5 rectangles. Did I get a better approximation? But it's still very much an under approximation. If I put in 20 rectangles, I'm getting closer and closer to the actual area. And here's the Riemann sum, here is the actual area. And I'll show you that number back at 3. My Riemann sum was 8, the actual area was 12. At 10, I'm getting closer to 12. If I put 36 in there, again, I'm getting even closer. So the idea is you want to put, really, in theory, you want to put how many in there? An infinite amount in there. Okay, your goal is to just keep filling, this is going to go forever here, but it's going to keep filling up with rectangles. So, everybody looking? We need to take the limit as n approaches infinity. What does this symbol mean from our Algebra 2 days? Summation. So you got to add up all your rectangles, right? So that's what this is saying, which is very convoluted. Would you agree?
Yeah.
The quick way to say this in calculus is just to write an integral. Say, add up all the area from here to here. The long way to figure it out is to take the limit, find the summation of the width times the height, and add all those up. This is what we're doing today. We're gonna feel very smart.
So there's 2 ways of doing it?
We're gonna feel really smart.
Why are we learning the long way?
All right, so instead of drawing all that out, I just showed the little piece up there. I want you to kind of box this in. Here we go. Okay, this is typically, I've never seen it as not a multiple choice. It's always been a multiple choice answer. So the integral of a to b, so again, we're adding up all the areas, is equal to this limit definition. Okay, and this is how I would get the exact area. This is no longer an approximation. This would get me the exact area. So your deal is you have to go both ways. They're either going to give you the integral, and you have to find the multiple choice that matches with this, or they're going to give you this, and you have to find the integral. So we've got to be able to go both ways. So we're going to try to break it down. So yesterday we talked that the width can be found by taking, I'm just going to draw a quick picture here. If I said this was 2 to 6, my width would be 6 minus 2 divided by the number of rectangles, right? That was the idea we used yesterday. Take the difference and divide by the number of rectangles. So we called the width b minus a over n. So right under here represents the width of the rectangle, this b minus a over n. Give me 1 second. Now you'll notice this says f of. When we say f of something, what is that finding? The y value. So this is getting the height because it's finding the y value. It's getting that height. Okay, so my height, and you just have to memorize this, is f of a plus b minus a over n times k. Okay, so, and we will put this on a card eventually. I have to memorize those too. Okay, so I have to find the limit expression that's equivalent to this. So I'm finding this half of the equation. So the first thing I always find is the width. Okay, the width is b minus a over n. So this integral is telling me basically to shade from 0 to 4. So if I'm shading from 0 to 4, I'm going to go 4 minus 0 over n, or my width is 4 over n. Fairly simple. Okay, so I have some function, it's a square root of function, so it looks something like this, and it's saying from 0 to 4, it wants the area under the curve. Okay, so I'm going from 0 to 4, or 4 minus 0 over n. Now to get the height. Okay, the height is, and this is the formula I kind of have to memorize, it's f of my a value. My a value is my beginning value, so my beginning value is at 0, plus my b minus a over n, which we already found is just 4 over n times k. And I can clean that up. 0 plus that is just f of 4 over n times k. Okay, now, I have to actually find f of this. If I asked you to find, if I gave you an equation and I said find f of 0, what do you do with that 0? Plug it in for x. So that's what you have to do. You have to find f of 4 over nk. So you're going to plug that in for x. So our height is equal to 2 times 4 over nk squared plus 3. I'm plugging in this for my x. Go ahead. Function notation, right? If I said find f of 0, you would plug 0 into your equation?
So you just turn the f into a 2.
I didn't turn the f into a 2. I'm using function notation. F of 0 means plug 0 into your equation, right? So I would plug in 0, and I would just get 3. Now I'm plugging in f of 4 over nk. So I'm plugging 4 over nk into my function. And I get this. Okay? So now I'm going to keep it simple for the first one here. I could say this is the limit as n approaches infinity of the summation from k equals 1 to n. And now it's just my base times my height. So I have 4 over n, there's my base, or my width, times my height. 2 times 4 over nk squared plus 3. No, we're not going to solve it. We're just matching it up. We do not have to solve that. Our goal is to match it up to the choice. Yes, this is as far as you have to go. You either have to write this side or you have to write this side based off what's given. Now, the only thing they might do, okay, they might actually do the math here. They might, I'm just going to go ahead and go one more step. They might square it or something, but I'm not solving it. K equals 1 to n, so I have 4 over n. So if I square this, what would I get? Perfect, and then I'm going to multiply that by 2. Can I just do, I'll write that up here. 16 over n squared k squared, and then I'm going to multiply that by 2. So they might actually write 32 over n squared k squared, and then plus 3. Okay, that's the only thing. If I don't see that choice, then I'll work out my math. Okay, but our job is only to match it up. We are not evaluating this. It's not calculator, it's not non-calculator. You just got to write the equation and match it up. So you only get better with practice. So let's try another one here. All right, number 2. Don't even. All right, so find the limit expression. So again, you have to say to yourself, I need a width and a height. So the formula for width, give me 1 second, is b minus a over n. So visually, again, I'm taking some function, and I'm finding the area between what two numbers? 2 and 5. So that's kind of like my a to b. So based off this equation, it's going to be who minus who? 5 minus 2 over n, or the width is just 3 over n. So getting the width is fairly simple, would you agree? Okay, now the height, you just have to memorize that rule. The height is f of a plus the b minus a over n, which you just found, times k. And who is a in our case? 2. So 2 plus 3 over n times k. Okay, now I have to go one step further because f of means substitute this into the letter x. So I'm going to say this is equivalent to 8 times 2 plus 3 over nk minus 2 plus 3 over nk squared. I'm substituting this into all my x's. And once you get those two, now you just put the formula together. So again, it's the limit as n approaches infinity. We want to add up from k equals 1 to n. And it's really just the width times the height. So my width was 3 over n. And the height is just this lovely answer. 8 times 2 plus 3 over nk minus 2 plus 3 over nk squared. And again, if I didn't see that as a choice, I would multiply in here and clean up, but hopefully they don't mess with you too bad. Okay, so again, we're always finding the width and the height, and then we're just putting them in there. Okay, so we went from integral to the limit definition. Now we're going to go the opposite way, from the limit definition to the integral. Okay, so I'm still going to start with the width. The width is b minus a over n. Okay, now, looking at this, you should be able to tell me what b minus a over n is. 3 over n. Does that make sense? So again, there's my width, there's my height. My b minus a over n is 3 over n. Okay, so now I should be able to figure out the a value. Again, just by looking at what's inside here. 5, because the formula is f of a plus b minus a over n times k. I see that sitting inside here. That means the a value is 5. So I can say b minus 5 is equal to 3. Would you agree I can kill these n's? They're equivalent. B minus 5 equals 3. Therefore, b has to equal 8. Okay, so that tells me this is the integral from 5 to 8. We said the a value is 5, and we just discovered the b value is 8. Okay, so now the question, who is the function we plugged this into? So we took care of the width. Who is the function that was plugged into? Sine of x, and that's it. We plugged this into, right here, in place of the x, which was sine of x. And that is the integral that represents this. So let me just say it one more time. I recognize the width. So I've got 3 over n. I can cross off the n's. I recognize the a, because it's a plus 3 over nk. I can easily find the b value, so I've got my bounds. And then I'm just saying, who was that plugged into? Right here, so it was plugged into the sine of x. Okay, let's try one more here. All right, take a look at 4. We want to start with the width, the b minus a over n. Where do you see it?
The 4.
Say that again. Not the 4. 5 over n, yes. Do you see how they kind of pulled it out front this time? They pulled it out front. They also, obviously it's in there as well, but they did pull that out front. So I'm just going to identify, there's my width. So 5 over n, it's just pulled out front. No, wait, well, think about, hold on. So I'm going to kill those for a minute. So I have b minus a equals 5. Based off what looks like was substituted in. So what looks like it's substituted in? Who's plugged into both of these? 5k over n minus 1. That tells me the a value has to be negative 1, right? It's f of a plus b minus a over nk. So there's my b minus a over n staring at me here, b minus a over nk. And they added to it a negative 1. So the a has to be negative 1. So minus a negative 1 is really b plus 1 equals 5. Therefore, b has to equal, shucks, I was going with 4.
I like 6. Sounds good.
Because it's b minus a negative 1, which is a plus 1. So that tells me the integral goes from, we said a is negative 1 to 4. Okay, now just look at it. Where did they plug this function into? They plugged it in twice, right? So what is the equation? Plus x plus 4. Yes. Okay, that is where they plugged the function in. So it was 2. They placed it in here, so that must have been an x. They placed it in here, that must have been an x. Okay, so we're just looking to see where it's plugged in. Say that again, Dree. It's x squared. Yeah.
I did not.
Right, because it's that quantity squared. Okay. So like I said, the only way to kind of get better at these is to practice. Now, the good, like I said, it's only been asked as multiple choice. So our goal is to match it up.
You're gonna just skip the trip to ask the question.
No, I'm just gonna go down 9th period now.
Dude, woo, woo, woo. 9th period's closed today.
I
There's nobody there.